Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we will be doing this chapter called as surface tension. We are going to do the numericals of surface tension. Please take down a capillary tube of 6 mm bore of 6 millimeter bore stands vertically in a glass vessel containing liquid of surface tension 30 dynes per centimeter. The liquid has specific gravity 0.9. Calculate the rise of liquid in the tube. Calculate the rise of liquid in the tube if G is 980 centimeters per second square. If G is 980 centimeters per second square. Now T is given by the formula RH rho G upon 2 cos theta. Therefore I can say that H is T into 2 cos theta upon R rho G. R is given to me, bore was 6 mm, that means radius is going to be 3 mm. I'm keeping everything in CGS system. Radius I know, density I know, gravitation, tension is given to you. Theta, since theta is not given to you, you will assume theta to be 0. So you will say let theta be equal to 0. When not given, you assume theta to be 0. You should be able to get the answer for this. The answer for this should be 2.268 centimeters. Next, a capillary tube 0.28 millimeters in diameter. A capillary tube 0.28 millimeters in diameter is immersed in a liquid of surface tension 0.048 newtons per meter if the density of the liquid is 940 kgs per meter cube. If the density of the liquid is 940 kgs per meter cube, find the height to which the liquid rises in the tube. Find the height to which the liquid rises in the tube. Find the height to which the liquid rises in the tube if the angle of contact is 24 degrees and G is 9.8 meters per second square. If the angle of contact is 24 degrees and G is 9.8 meters per second square. So I can say H is equal to 2t cos theta. Similar formula, that same formula in fact that we used in the previous sum upon R rho G. Here theta is also given to you, straightforward sum T, theta, R, rho and G. Everything is given to you. Should get the answer for this sum as 6.8 centimeters. Next, take on next sum please. A capillary tube. A capillary tube is dipped in water. The water rises in the tube. The water rises in the tube. Water rises in the tube by 9 centimeters. Find the diameter of the tube. Find the diameter of the tube. If the tension is 70 dynes per centimeter. If the tension is 70 dynes per centimeter. If the tension is 70 dynes per centimeter. Now, let's see this. G is going to be nothing but 980 centimeters per second square. They've asked you to find out the diameter. That means I need to know the radius. They haven't given you the angle of contact, so I can assume the angle of contact to be 0. It is dipped in water. That means rho is going to be 1 gram per centimeter cube. Right? Now I can use the formula. I can say that T is equal to H R rho G upon 2 cos theta. You have to find out R here. So I can say R is equal to 2T cos theta upon H rho G. Substitute the values. You should be able to get the answer for this. The answer for this should be 0.0318 centimeters. Next, take on next one please. Sorry. A liquid of density 900 kgs per meter cube rises to a height of 9 millimeters in a capillary tube of diameter 2.4 millimeters of diameter 2.4 millimeters. If the angle of contact is 25 degrees, if the angle of contact is 25 degrees, find the surface tension. Find the surface tension if G is 9.8 meters per second square. If G is 9.8 meters per second square. Let's see this same formula that we've been using. T is equal to RH rho G upon 2 cos theta. RH rho G 2 cos theta. All the values are given to you. The answer for this sum should be 5.255 into 10 raised to minus 2 newtons per meter square. Next, take on next sum please.
Okay.
A capillary of 1 millimeter radius. A capillary of 1 millimeter radius is immersed in mercury. The level of mercury inside the tube, is found to be 0.536 centimeters, 0.536 centimeters below the mercury in the reservoir. Find the angle of contact below the level of mercury in the reservoir. Below the level of mercury in the reservoir. Find the angle of contact. Find the angle of contact if the surface tension is 0.405 newtons per meter. If the surface tension is 0.405 newtons per meter, density of mercury is 13.6 into 10 raised to 3 kgs per meter cube. 13.6 into 10 raised to 3 kgs per meter cube. And G is 9.8 meters per second square. Now, I can say T is equal to RH rho G upon 2 cos theta. So in that case, I can say that cos theta is RH rho G upon 2T. Therefore, theta is going to be cos inverse of RH rho G upon 2T. First get the value of RH rho G upon 2T. Find the cos inverse of it. You should get the answer for this. The answer for this should be 151 degrees 53 minutes. Next, take on next one please. Liquid rises to a height. Liquid rises to a height of 12 centimeters. Liquid rises to a height of 12 centimeters in a capillary tube of radius 0.03 centimeters. What will be the height of the liquid column? What will be the height of liquid column in a capillary tube of radius 0.06 centimeters. In a capillary tube of radius 0.06 centimeters. Now, we know that H is equal to 2T cos theta upon R rho G. That means I can say that H is inversely proportional to R. Therefore, I can say that H1 upon H2 is going to be R2 upon R1. Right? Once you have this, you have three values. You can find out the remaining value. The answer for this should be 6 centimeters. Next, take on next one please. Calculate the work done. Calculate the work done in blowing a soap bubble. Calculate the work done in blowing a soap bubble of radius 0.5 centimeters if the surface tension of the soap if the surface tension of the soap is 25 into 10 raised to minus 3 newtons per meter. Now guys, if a soap bubble is blown, you will get a sphere. What is the surface area of a sphere? Surface area of a sphere. If you blow a soap bubble, you are going to get a sphere. Surface area of a sphere is nothing but 4 pi r square. Surface area of a sphere is 4 pi r square. Now, the bubble has two free surfaces, the outer and the inner. But the bubble has two free surfaces, right? Therefore, I can say that increase in surface area as you blow the bubble, increase in surface area is going to be 2a, right? Now, that means this is going to be 2 into 4 pi r square, that is 8 pi r square. Once you know this, then I can find out work done. Work done is given by the formula of surface tension into increase in surface area. Tension we know, T into increase in surface area is 8 pi r square. Radius is given to you, T is given to you. You should be able to get the answer for this. The answer for this should be 1.57 into 10 raised to minus 5 joules. Next, take on next one please. Find the work done. Find the work done in blowing a soap bubble. Find the work done in blowing a soap bubble of radius 5 centimeters when the surface tension is 25 dynes per centimeter. I'm not even solving this, it's a replica of the previous sum with the same numbers, except that was in SI units, this is in CGS units. So you will get a similar answer. The answer for this should be 15700 ergs. Next, take down next one please. Calculate the work done. Calculate the work done in increasing the radius of the soap bubble. In increasing the radius of the soap bubble from 1 centimeter to 2 centimeter if the surface tension is 30 dynes per centimeter. If the surface tension is 30 dynes per centimeter. Now I can say that increase in surface area dA is nothing but twice the new area minus the original area. So this is going to be twice A2 minus A1. soap bubble is going to be in the form of a sphere. So 4 pi r2 square minus 4 pi r1 square, right? 4 pi common, so 8 pi r2 square minus r1 square. Once you have this, then you can find out the work done. Work done is T into change in area. You have T, you have change in area, you can substitute and get this answer. The answer for this sum should be 2260.8 ergs. Next, take on next sum please. A glass plate 9.5 centimeters long and 0.5 centimeters thick is suspended in a trough containing water. Suspended in a trough containing water, so that the length touches the water surface. Calculate the downward force due to the surface tension. Calculate the downward force due to the surface tension acting on the plate. If the surface tension is 72 dynes per centimeter, if the surface tension is 72 dynes per centimeter, if the surface tension is 72 dynes per centimeter, now this is your beaker, trough containing water. Now if I want to suspend a plate on this surface, what will be the total length of the plate that will be in contact with the water surface? The total length of the plate which will be in contact with the water surface will be the perimeter of the plate. Therefore I can say that let capital L be perimeter of plate. So in that case I can say L is twice L plus T. That will be the length of the plate that will be in contact with the water surface. Once I know the length of the plate which is in contact with the water surface, see how, if you want I'll show it to you. This is given to you as, understand this concept please people, this is 9.5 centimeter and this thickness is 0.5 centimeters. So this will be the entire length that is going to be in contact with the water surface. Once I have this, then I can use my basic formula. Surface tension is force per unit length. Therefore, force is tension into length. Length you already found out, tension is given to you. You can multiply and get the answer. The answer for this should be 1440 dynes. Next, take down next one please. A glass plate of length 8 centimeters, a glass plate of length 8 centimeters, breadth 6 centimeters and thickness 0.3 centimeters is held vertical with its longest side touching the surface. What is the force of surface tension if surface tension of the water is 0.07 newtons per meter? If surface tension of water is 0.07 newtons per meter. Excuse me?
What is the force?
What is the force of surface tension acting on the plate? Now, guys, they have specifically said that the plate is held vertical. Now, since the plate is held in vertical position, then the surface of the plate that will be in contact with the water will be the length and the thickness, because the plate, instead of being held horizontal, is held vertical. If it is held vertical, that means the length of the plate is going to be in contact with the water and the thickness of the plate. Therefore, L is going to be twice L plus T. Once I know this, then I can say that surface tension is F upon L. Therefore, I can say that F is equal to TL. You should be able to get the answer then, right? The answer for this sum should be 1.162 into 10 raised to minus 3 newtons. Next, a wire ring of 4 centimeters radius, a wire ring of 4 centimeters radius, a wire ring of 4 centimeters radius, a wire ring of 4 centimeters radius is rested on the surface of the liquid, and then raised. The pull required is 4.07 grams. The pull required is 4.07 grams more before the film breaks. Before the film breaks, calculate the surface tension. Ring resting on the water surface. What will be the length of the ring which will be in contact with the water surface? The length of the ring in contact with the water surface will be circumference. Now both the surfaces of the ring, the lower surface and the upper surface, are going to be in contact because you are touching the water surface. Therefore, this is going to be 2 into circumference. If I am going to rest the ring on water, both the surfaces of the ring are going to be in contact with the water. So the lower length and the upper length are going to be in contact with the water. Therefore, twice circumference. This is 2 into 2 pi r. Once I have this, then I can say T is equal to F upon L. Force they had given you in terms of grams, I converted it into dynes. How did I do that? We know that F is equal to mg. So I used G as 980 dynes, and that's how I got this 980 centimeters per second square. So you will get your answer here. The answer for this sum should be 79.39 dynes per centimeter. Next, a circular loop of radius 7 upon pi centimeters is suspended from a balance the loop is in contact with soap solution. The loop is in contact with soap solution. The loop is in contact with soap solution. The pull on the loop is 0.6 into 10 raised to minus 3 kg weight. 0.6 into 10 raised to minus 3 kg weight. Right? Calculate the surface tension. Calculate the surface tension. Now guys, the loop is going to be in the form of a ring. The length of the ring is the circumference of the ring. The loop will have two faces, the lower face and the upper face. Both are going to be in contact with the soap solution. Therefore, the total length of the loop which is in contact with the soap solution will be 2 into circumference of the loop. That is going to be 2 into 2 pi r. Once I know this, then I can find out T is equal to F upon L. Right? Next, take down next one please. The answer for this sum should be 21 into 10 raised to minus 3 newtons per meter. Next. Now mark this next sum as very important. Just in case, due to unavoidable circumstances, you are not able to do the chapter, make sure that you do this one particular sum very thoroughly from this chapter. Calculate the work done. Calculate the work done when a spherical drop of mercury of radius 2 millimeters when a spherical drop of mercury of radius 2 millimeters is broken into million droplets each of the same size. And the surface tension of the mercury is 460 into 10 raised to minus 3 newtons per meter. Now, one drop breaks into a million droplets, right? Even if one drop breaks into a million droplets, will the volume of mercury change? No. If I break a single drop of mercury into million droplets, even then the volume of mercury should remain the same. Therefore, I can say that volume of drop should be equal to 1 million. 1 million is 10 lakh. Should be equal to volume of 10 lakh. Volume of 10 lakh droplets. Right? Drop of mercury is in the form of sphere. Volume of sphere is 4 by 3 pi r cube. I'm assuming capital R to be the radius of the drop is 10 lakhs into volume of droplet 4 by 3 pi r cube. I'm assuming small r to be the radius of the droplet. 4 by 3 pi and 4 by 3 pi gets cancelled. R is given to you as 2 into 10 raised to minus 3 is 10 raised to 6. 2 into 10 raised to minus 3 is 10 raised to 6 r cube. Right? So in that case you will get
2 into 10 raised to minus 3 the whole cube.
2 into 10 raised to minus 3 the whole cube. Right? So if I take cube root on both the sides, I will get 2 into 10 raised to minus 3 cube root is 10 raised to 2 r. Therefore I can say small r is 2 into 10 raised to minus 3 upon 10 raised to 2. So 2 into 10 raised to minus 5. That will be the radius of each droplet. Right? Now let us find out the increase in surface area. Increase in surface area will be nothing but the surface area of million droplets minus the surface area of one big drop. Increase in surface area is the surface area of million droplets minus surface area of drop. Right? Surface area is nothing but 4 pi r square. 4 pi r square million 10 raised to 6. So 10 raised to 6 into 4 pi r square minus drop 4 pi r square. So this is going to be 4 pi common. So in that case you will get this as, I could say that small r, guys, this is 10 raised to 6 into 4 pi. Small r is nothing but capital R divided by 100. Capital R divided by 100 the whole square minus 4 pi r square. Guys, if you look at this equation, this is capital R. Capital R divided by 100 gives you small r. Right? So in this case, this is going to be 10 raised to 6 into 4 pi r square upon 4 minus 4 pi r square. 1, 2, 3, 4. So this will become 10 raised to 2. 4 pi r square common. This is 100 minus 1. Right? So this is going to be 99 4 pi r square. That's my increase in surface area. Once I know increase in surface area, then I can find out the work done. I can say work done is tension into increase in surface area. Tension is given to you, increase in surface area you just found out. You also found out the radius of the droplet, so you should be able to find out the work done. Fine, do we get this thing here? So when you calculate this, the answer for this sum should be 2.288 into 10 raised to minus 3 joules. That will be the work done in converting one drop into a million droplets. Next, take down next one please. A drop of mercury of radius 1 millimeter is broken into 8 droplets of the same size. Find the amount of energy needed if the surface tension of mercury is 540 dynes per centimeter. 540 dynes per centimeter. Replica of the previous sum. In the previous sum they had asked you work, in this sum they have asked you energy. Whether they ask you work or energy, it's the same thing. You still use the same formulas. 10 raised to minus 1, you're converting into centimeter from millimeter to centimeter. Right? Because this tension is given to you in dynes per centimeter, it's given to you in CGS system. Now, I'm not even solving the sum, you should be able to do it exactly like the previous sum. The answer for this sum should be 67.82 dynes. Next, take our next sum please. 8 droplets of mercury. 8 droplets of mercury combine to form a single drop. 8 droplets of mercury combine to form a single drop. Find the change in the surface energy find the change in the surface energy if the surface tension of mercury is 0.465 joules per meter square. Just see whether I have dictated the sum correctly. 8 drops of mercury of radius 1 millimeter. Did I dictate radius 1 millimeter? Please write that. 8 drops of mercury of radius 1 millimeter combine to form a single drop. Find the change in the surface energy if the surface tension of mercury is this. Now very similar, there you have broken the drop, here you are going to combine the drop. Now whether you break or combine, I can say that the volume of 8 droplets should be equal to the volume of drop, right? So 8 volume 4 by 3 pi r cube should be equal to 4 by 3 pi r cube. 4 by 3 pi gone. Take cube root on both the sides. So 2r is equal to r. Right? Once you have this, let's find out the change in surface area. Change in surface area is nothing but the surface area. Now I'm making a big drop. So it will be surface area of the big drop minus surface area of 8 droplets. Surface area of drop minus 8 into surface area of droplets. Right? Now, surface area of the drop is going to be nothing but 4 pi r square. So this is 4 pi r square minus 8 into 4 pi r square. This is 4 pi r square minus 32 pi. The value of small r, no, the value of capital R is this. So we leave this as it is. I could take 4 pi. The value of capital R you found out is 2r, the whole square minus 32 pi r square. 4 pi into 4r square minus 32 pi r square. 16 pi r square minus 32 pi r square. That's minus 16 pi r square. The negative sign indicates that there's a decrease in the surface area. Right? Negative sign indicates a decrease in surface area. Once I know this, then I can find out the surface energy. Surface energy is the same as work done, which is T into change in area, right? T is given to me as 0.465. 465. Change in area 16 pi r square. Substitute, you should get the answer. The answer for the sum should be minus 2.337 into 10 raised to minus 6 joules. Okay, we'll stop this here for the day. Thank you very much.